All right, so conclusion with that, there should be a list that you can see. If you can't track it down, just send me an email and then I'll reply back with the list because I still have them all. I wrote everything down on paper before I actually submitted grades, so I've got it for you. Okay.
It's horribly blurry today. I don't know why it's doing that. Fix a little bit. That's nasty. It's coming up better now. No, not really. Okay. Here's the paper. So this is 5C. It's super blurry today. 13, 15, 17, 21, 25, 31, and 35. So 13 is the first one. So 5C, we're making what, frequency tables, I think is one of the things we're doing. We're doing a few different graphs. We did histograms and bar charts and did some pie graphs and even did some line plots or some line graphs and dot plots. So 13 tells us to do a frequency table. They give us the 5 grades of 30 students. And so we have a bunch of A's, B's, C's, D's, and F's. And so we want to make a chart. F and the total should be on there. So my chart looks something like this. So you should have the grades. The first thing should be the frequency. So if we're looking at the frequency, so basically if we're looking at the frequency, all we're doing is counting how many A's there are in that list. If we count how many A's, I believe there are 6 A's. Let's see if I get it. 6 A's. There are 6 B's. There should be 10 C's. There should be 5 D's, and there are 3 F's. If we total them, that should be the total of 30 that we're talking about. So one thing about this section, it doesn't have a whole lot of like homework problems to do, but like part of that is because all these are pretty much like making a graph or making some sort of table. It's going to take a bit of time to do them anyway, so they don't give you many of them, but the ones that they do give you are going to take you a little bit of time probably. Any questions about this, how to get this much of the table? So they want us to do frequency. The next thing on here is relative frequency. As you see, we're going to take the frequency, which is 6. So there are 6 A's, and that 6 is occurring out of 30 total different possibilities, or 30 different outcomes. And so relative frequency, we kind of talked about this, but this is sort of like the probability, right? That an A is going to occur or something like that. And so this is giving you, you could think about that as being like maybe 20% or something. It's 0.20. If 6 out of 30 is 20, and that's also 20.20. Then we have to do 10 out of 30, which is a third, so 0.33. We're doing 5 out of 30, so that's, what, half that amount? And I believe they rounded up. It should be like 0.166. We're going to round to 0.17. So they rounded everything to 2 decimal spots for this. I believe if you round to 2 decimal spots, you should be all right. We're doing 3 out of 30. That's a tenth, an even tenth. If we add these all up, what should these things add to, I guess is my question. Well,
It all
since
adds to 1, correct?
yeah, they should all add to 1, because if we think about it, if each of these has a percentage that they're going to happen, the percent that one of these you're going to either make an A, B, C, D, or F is going to be 1, right? And so this is like adding up all the possible total outcomes. It's going to equal 1. And so hopefully that should make a little bit of sense why it's adding up to 1. One of those things is going to happen. We're guaranteed one of those results, right? So frequency, relative frequency. The next thing, let's see if I can do it. What you're running on right here is cumulative frequency. I believe it's the last thing I asked for. So cumulative frequency, we take the frequency. So this one happens 6. And so there's like a statement I could probably make here. A total of 6 people had A's. If I'm looking at this 6, I'm adding another 6 here. So a total of 12 people, you could say, had either an A or a B. If we look for A, B, or C, we're going to have to add this 10 over here to it. So 10 plus 12 is going to give me 22. So you got 22 people that made A, B, or C. And you probably see the pattern by this point, hopefully, but we're doing what? 22 plus 5 there should give you 27.
And then 30.
And then 27 plus 3 should give you 30. There is a total of 30 people all in all, right? And so this is probably like kind of useful, because you can also see right away that like what 22 people made A, B, C. So if you consider an A, B, or C to be passing, you can like kind of look right here right away, figure out how many people are passing the class.
So in the relative frequency, you don't make it percent.
No, they're leaving it as a decimal, so it's a probability sort of thing.
Mhm.
So think of this as a probability, not. And there is a relation between probability and percent, right? You just move the decimal two spots. So there is a relation between the two, but they want to consider these as sort of like probabilities, right? And 1 is guaranteed that that thing is going to happen. 0 is no chance in heck. So we made a frequency table. We added relative frequency, and we added cumulative frequency to that thing. Start asking you all some of these questions. Let's go in order. Okay, so Veronica, 15 ask you to analyze if that's qualitative or quantitative, and they say the eye color of students in a class. So we're talking about the eye color of students in a class. Is that qualitative or quantitative?
I versus students. Qualitative.
Yeah, it would be qualitative. Like what? And what's some sort of reasoning on where you're saying qualitative?
Because of the color,
Uh-huh.
eye color, and also the students, the class.
Yeah.
There are no numbers.
Yeah, exactly it, right? It's not a number. You're just giving a sort of name, right? Blue, brown, green, whatever you want to say. So it's qualitative. Like one of the dead giveaways is we're not talking about a number. It's like a category, right? And so there's kind of like, I don't know what I'm saying. at first, I feel like when I first heard about qualitative, quantitative, it was like, oh yeah, that makes sense. But then there's a sort of thing, even with like qualitative things, with like color, you can actually think of color as like wavelengths, right? And different size wavelengths actually give you different colors. So there are numbers that we can kind of assign to these sort of things, but it's sort of in the way that they talk about it. They didn't talk about wavelength or give us a number when they gave us this. They just talked about like sort of like eye color, right? And that's categorical then. And so that would be qualitative.
So wouldn't it be so like having an eye color is a quality? So that's kind of giveaway right there, maybe.
Yeah. Yeah, there's also like the fact that like usually with quantitative you can take some sort of metrics and you can take like statistics on them. So if we were talking about the wavelength, we could like take the average of the wavelength. But if we're talking about like, you know, red versus, or that's not red, like blue versus brown, we can't really take the average of blue and brown, right? Those words, it doesn't really make a lot of sense. So it's categorical, it's qualitative, it's not a number. 17, who wants to answer? Jorge, are you around here? He's probably awake.
I'm around here. Hold
All
on.
right. 17, home prices in a small town. If we're talking about home prices, that's definitely what sort of variable?
Give me a second. Trying to find it. That would be quantitative.
Yeah, it's quantitative. Why? Why are you saying that?
Because it's a bunch of houses.
Yeah. But what about the houses? It's a the word I use is it's measurement, right?
Okay.
I think is the key word. I think that they had in their definition that I kind of picked up on. So if it's a measurement, it's definitely quantitative, right? We can take the average price of a house. We can figure those sorts of things out on those numbers. Because in qualitative, we can also have numbers, but they don't have the same meaning like we have, right? They're used categorically, and it's kind of a weird thing. I'm not sure if we have examples of that in here, but it's a thing that could happen. Okay, and then 21, who's around? Anaisa, are you around?
Yes.
What'd you say for 21? It says the annual salaries of NBA basketball players.
It would be quantitative also because the salaries are recorded values.
Yep, it's a value, it's a measurement. Yep. We could take average salary. Anybody have any questions on these sort of things? How do we differentiate like qualitative from quantitative? This is going to go way too fast if I don't make a graph these things. The graphs are the thing that take like the most time in this. Oh, man. Okay. 21, the next one we're doing is 25. Okay, so 25, they give us this table. Zoom in, get any less blurry or not?
It's very blurry.
Yeah. I'm wondering if there's a setting on here. I can't really see it though. Is there a setting that would make it better? No, it's just. No. That's horrible blur, huh? Okay, let's just go with it. The following table gives the populations of 5 most populous countries, 2016. Make a bar graph for these data. Bars in descending order. So they're giving us China has 1374, India has 1267, the US has 321, Indonesia has 358, and Brazil has 206. And so last time, you were talking about population. So this time, we actually are talking about populations, meaning the population of the country. I know that was probably a little confusing. So we want to make a bar graph or bar chart. This I already did. And so the first thing is we need a title for our bar chart. So 5 most populous countries. The other thing for our y-axis, we're going to put the population. For our x-axis, it's going to be the country. So maybe first we might want to do a little bit of like calculating to see what sort of intervals we need to go by. So I did a little bit here. So if we think about, we need to go up to 1400. China had 1374.
14.
So if you want to do 1400 by like 10 tick marks, each one of them has to be at least what, 140. So I rounded up. I'm going to go by like 200 in my y. So if you look at my y, if I do things by 200 in my y, that should give me all I need. Here's a pro tip. If you don't have graph paper, you can always Google free graph paper and print out graph paper. That's probably what that is what I did on here. It's got a little tag on there. Printfreegraphpaper.com, something like that. But if you just Google like free graph paper, it might help you when you're doing these charts to kind of keep things straight.
Oh, okay.
And so that's basically what I did for this graph paper. We do those by 200. We put the countries down here. Probably need to zoom out a little bit. And so be sure to label your axes. So this is the country, China, India, US, Indonesia, and Brazil. This is the population on the y-axis. And then the other thing that you better put is that this is in millions, right? And so for the first bar for China, it should be what, 1374? So I did these big, beautiful bars and filled them in. Let's come up a little bit. Come down with the paper a little bit. There we go. And where's next? India. And so maybe one thing you might want to note at this point is like these bars, they're not touching, right? They are separate. If we look at the x-axis, they're all divided into categories, right? And so we should see, hopefully, each of these countries, right? So China is about 1374 right here. India is 1267. It's not quite going to the 1300. It's about halfway between 1200 and 1300. The US is 321. Indonesia is 258, and Brazil is at 206. And I said it, and so I'm going to say it again, I think. But these bars aren't touching. If we were like to put these bars together, it wouldn't make a whole lot of sense, right? There's not, like, this is not a continuous line here. It's divided into different categories. And so that's one of the differences between a bar chart and histogram.
When do we combine them and when do we separate them?
So these are by category. So these are going to be separate because they're separate categories, right? There's not like anything that's sort of like, it's not going from one to the other sort of thing. It's not a numerical quantity on this axis. It's categorical, right? It's qualitative, not quantitative, right? Is the words that we used. And I'll have a histogram on here in just a minute, and so we'll be able to like probably put them both on here and compare and contrast a little bit more. And if you looked in the back of the book for their solutions, they didn't draw them correctly. I don't know how to tell you that, but the back of the book solutions, they didn't draw their histograms correctly very well. Okay, that was 25. The next one is 31 is the next one that we're doing. And it says the following table shows the number of cell phone subscriptions in millions in the US for various years. Construct a time series graph for the data. Does the graph show straight line growth, linear growth, or growth faster than linear? The number of subscriptions can be larger than the population because some people have more than one subscription, such as for personal and business phones. Okay. And so they give us the year 1997, 99, and they're going to every 2 years, I believe that they're giving us. And they're giving us some sort of number in millions for subscriptions of cell phones. So again, if that y-axis, if we're doing, I believe the largest number is 378. So we need to go up to about 400, right? And so if I'm doing 400, I think I divided 400 by 10. That's going to give me 40. So I need to go by at least 40. And so I think I rounded it up to 50. And so if I go by 50s on my y-axis, I think I'll be safe. I think I'll be able to get everything on there. And so I went by 50 on my y-axis. I went every 2 on my x-axis. Okay, I want to label things. So these are my years on my x-axis. This is my subscriptions, my cell phone subscriptions in millions. And so be sure to put your units on there. 400 million is a lot more than 400. And then we're doing a x comma y sort of graphing, right? This looks like, if we go back to this chart, here it is. We're just using x as my year. So this is my x, this is my y. I'm just graphing x and y, right? So 1997, 55 is the first thing that I'm graphing on here. And so let me just throw these out at you. Cover up what it said here. Another thing that I didn't say outright. I can cover this up. No. Let's just do it. So one thing I didn't mention was I need to put a title on here. US cell phone subscriptions is what we're talking about here. No, the screen's still blurry. Yeah, it's a little blurry today. I'll try to fix it by next class, hopefully. Try to figure what I can do about it. And so things I was graphing is 1997, 55 is about where this is. This is 1999, it's about 86. 2001 is about 128. This one is about 159 in 2003. That point, the one with the X through it, should not be there, so pretend like that thing's not there. 2005 is about 208 if we go across. This one's about 255, 286, 316, 336, and 378 should be that last one. And if we're looking at this, we plot each point, and then we draw a line between each consecutive point.
Which one are you working on 31?
Yes, this is 31.
What are your years down there? Because I have 97 going up to 2005.
It should go up to 2015.
Okay, I see.
This is 97, 99, 2001, 2003, 2005, 2007, 2009, 2011, 2013, 2015.
Okay.
So each bar should be a year, basically. Because I think I skipped one. If you can see those, the minor grid lines in there. And so we're looking at this. How do they ask it? Does the graph show straight line growth? Is it linear growth or is it faster than linear? So is this going to be like exactly a line? I guess is the first question. Like, if we put a straight line over this thing, is it going to hit all those points?
No.
No, but is it going to be approximately close to those points?
Yes.
Yes, right? And so is it linear?
Yes.
Yeah, it's about linear, so you could say yes, right? That's about a linear growth. And
Is this just like a linear versus exponential growth thing?
yeah, that's kind of what they're asking. Does it look exponential? Does it look logarithmic? Like, how does it look? It's kind of what they're asking. Does it matter how you assign the X versus Y labeling? The labeling should be the same. Are you talking about the numbering on the X and Y axis? If you're talking about the numbering, where I put the dates. Oh, yes. So it does matter which one you do on your X and which one you do on your Y. If they give you a year or a time, typically years or time, any unit of measurement of time, is typically going to be on your X axis. And also this goes back to independent, dependent sort of variables. We typically see the subscriptions as being a function of the year, as a function of time. Things are, you know, everything is a slave to time, as the saying sort of goes. Yeah, good question. X, Y, it's about linear. If I wanted to draw something about linear, like I could draw a sort of line that goes in the middle. Is it going to hit every point? No, but is it going to be a pretty good predictor of what's happening? Yeah, right? And even then, like, when you say pretty good predictor, like, you're talking about millions of subscriptions here. You could be a couple million off. Like, it's a relative term, right? Oh, okay. 31. And the last one we did was 35. 35. Okay. What is 35? I've got in there. Frequency table categorizes Nobel Prize winners. Analytics here by their age at the time they received the award. Display the data in history and write a short paragraph explaining useful trends or patterns. So they gave us a table that has ages, and then it has the frequency or the number of winners in there, right? And so we want to make a sort of like frequency graph. That's what the histogram does. And so let me cover this appropriately. You should put a title on their age of Nobel Prize winners. If we look at the age of the Nobel Prize winners, or the largest number, it's on this table. The largest number on there, I believe, is 19. So we need to go to at least 20. And so I think I just did them one by one. And you can probably sort of already see this, but that's the number of winners. On my x-axis, I want the age. So that's the number of winners, 0 to 20. On this one, I want my age. And so I need to go, the highest one, I believe, was like, what, 85 to 90, or was it 80 to 85? I can't remember what was on it. I need to go all the way to 90. I need to start at 50, so 50 to 90. And I did a little thing here that says less than 45. So I want to go everything from less than 45 up to 49. There should be 9 of those people in that group. So if we look at that table, that first number should say 9, right? The next one, I believe, is 10. The next one jumps up to 18. From 65 to 60. The next one from 60 to 65, I believe, is another 18. So I know it might look like one bar, but there's like kind of 2 bars in there, right? 65 to 70, I believe that's when it jumps up to 19 people. 70 to 75, it's back at 18. And then 75 to 80, it starts going back down 15. And then 80 to 85, there's like 4. And then 85 to 90, there was 2 of them. And so we get this sort of shape. And maybe
Do they have to be touching?
they should be touching. And hopefully that makes a little bit of sense, because here we're going from 45 to everything less than 50, right? Up to 49. Here we're going from 50 to 54. Here we're going from 55 to 59. And so if right after you hit the age of 59, the next thing you're going to hit is the age of 60, right? And so this axis is like, it's a continuous sort of axis that's happening down here, right? We don't have separate compare and contrast, right? That's what we need to do. We don't have this sort of thing happening, right? From this previous one. It looks very different. They look a lot alike, but they have their differences, right? I guess is what I should say. It's all the same, but different. So if we look at this is a continuous axis down here. This one is going to be different qualitative categories, right? This one's going to be quantitative. This one will be more qualitative, right? And I'm not sure if Mr. Martinez is around, he might want to answer, but they don't exactly explain how to do this in the book.
All right, can you repeat the question? I was grading
They
some
don't
papers.
they don't exactly explain how to do this part. It is like if it's 50 or less than 50. And so I said, since I was going by fives, I just said less than 45, 45 or less here.
You
And
mean just
so-
like that empty space?
Yeah, because this goes all the way down to 0 technically, right? It's going from 0 to 50.
I think you can just skip over it. You don't even have to do those little zigzag marks in them. I think you start
I was
whatever interval you want to, as
Yeah,
long as you're increasing and they're spaced evenly.
Yeah, because these have to be spaced evenly, right?
Yeah,
And so I was
that's
thinking
an absolute.
that this has to be everything less than 50 is what they said. There were 9 people that were younger than 50, and I wasn't sure exactly how to do that with the bar.
Oh,
Yeah.
what question is that one?
It is 35. And if you look at the back of the book, they're absolutely incorrect with the way that they draw the histogram back there. So that might be worth noting. They put spaces in the histogram, and there shouldn't be spaces in there.
Yeah, okay. They can't do that. All right, the rules to histograms. Hey, hold on, there's a car starting in my garage. Give me a second. Okay, can you hear me?
Yeah, we can hear.
I don't know, there's a car in the background probably. All right, the rules to histograms is that all of the intervals have to be the same size. So it looks like they're doing increments of 5 for each one. So that 9 number of winners that are less than 50, you can't do a bar for them because you need to know where they really are. So they might just be a bunch of single, frequencies in different spots, and you have a whole bunch of little ones out there. That really shouldn't, they really shouldn't do that. Does it say something in the,
I don't know, because the back of the book is absolutely wrong with what they give you. Because they put spaces in their histogram, and you're not supposed to have, like, spaces. They almost do it like categories. Like, it's really weird, because they're doing it almost like a bar graph, and they shouldn't be doing that.
all right, let me just double check that real fast.
Well, here's something that you probably know. If we're having a hard time figuring it out, this is probably not going to be a question we give you. This is kind of an odd question.
Yeah, I mean, if everybody has access to the book, or can you put the book under there? Do you have that? I know that's blurry, but it'll be all right.
35.
Oh no, the answers from the back of the book.
Oh, no, I don't have the solutions, and I didn't put those out.
Okay.
I have a picture of it.
Yeah, I can bring it up right.
Yeah, if you want to turn your camera on.
It's on my phone, so I don't know how well you can see it.
Actually, that's pretty good. All right, so if everybody could look at Brittany's screen, just for a sec there. All right, what Seaver said about histograms, as far as like the spacing between the bars, he's absolutely right. The main thing about histograms is that you don't have bars between them. You want to have these tight intervals that data fall. I always call them bins. Oh, they call them bins too, don't they? These are called bins, and you sort of like fill them up with data. Every time you have one piece of data that can go into a bin, it goes in there, and the bin goes a little bit higher. You should not have any spaces between them because there's no gaps between the intervals on there. That bar that's at the very beginning where it's the value of 9, that's just described as being less than 50, that is just fundamentally wrong with histograms. The rule of histograms is that you have to have evenly spaced intervals, and And that means every bar can only be worth 5. So what they're making the claim there is that that bar is worth 50 units in width. So, all right, Brittany, you're good. You can put it down. All right, the graph that Sievers has, your first bar, is that 9? Is that what that is?
Yeah, that's the 9 right here.
The way that I would describe that to everybody is his histogram looks great, except that first bar just can't exist. You can't do that with a histogram. You're not allowed to do that. And you should never really be asked to do that because you can't.
Is that because it's bigger than the increments we have down afterwards?
Yeah, that'd be the
Yeah.
answer to it. Yeah, absolutely. Like the width of that bar has an interval of 50 units all the way from 0 to 50, but then everything after that's a 5. And that's an important aspect to the histograms, because if you're changing the intervals, then the picture doesn't tell you anything.
Yeah,
You
it's
see
gonna
how you get that highest bar in the middle? That one that's just a tad bit larger than the others? If we were to go down and look at the bottom where it said 65 to 70 and find out that that was actually 65 to 75, then that bar has no business being that tall and it's misleading information. The only way the histogram works is if we understand that every one of the bars is the same width for values. Yeah. Anyway, it would be, his graph would be a great answer if we just didn't have that 9 and it was just not there at all. That'd be great.
So can you start a histogram? It doesn't have to start right at the beginning. You could start it on the 50.
And that's how it should be. I think the way the textbook should rewrite the problem, they should not have the less than 59 winners. They should not have that at all. Just take that row out. And if they would just take the graph that they showed, which is what Sievers says here, and just push all the bars together, then that would be perfect.
Yeah, because this gets a little taller than what it actually should be. It looks taller than what it should be. It should be spread out like more like down here.
Yeah.
It should have more of this sort of shape happening.
Okay. I think that's all I have on that. I'd probably start repeating myself.
And I believe like next week, I believe we go into like skewness and stuff like that. We'll start talking about that. And so this is kind of leading into that a little bit. It changes how your skewness kind of happens when you do things like that.
Man, I'll just repeat one more time. That beginning, so when you look at the table that's in the book, that line that says less than 59 winners, you cannot have a line like that on a table and then build a histogram from it. It's just plain wrong. You're not allowed to do that. Okay. Okay.
So don't do this one, not this bar.
Yeah, just take it out.
And then they asked about sort of trends. Can we see any sort of trends or anything happening with this problem? What do we want to say about this problem?
Nobel Prize winners are between the ages of 60 and 80.
Yeah, I went with 55, right? I think 55 is where it starts here, between 55 and 74, I guess is what it goes up to, right? 55 and 74, most of those people, I think if we total them, that's what, 73 winners, I think is what I said. So you have like 73, if we total all the winners, that's out of 113 total winners. So most of the people are between that age range, right? So that's a good thing to notice. The further right we go, you might notice it starts like weaning off really pretty quick. It would look pretty similar over here if we graphed it appropriately, but it sort of weans off over here. We're looking in the middle. So there's this thing that we like to talk about in statistics They call them measures of like central tendency is a fancy word that they use. But basically, we want to talk about like the average age of a person that won the Nobel Prize. And if you want to talk about the average age, you could probably say it's around what number?
65.
Yeah, 65 to 70, probably right in here in 65. It looks about the middle, right? This is 1818, 1818 on each side. You got about 36 on each side right here out on this hump. So I would say 65 is about the middle. And so there's three different things that they use to kind of talk about the middle, and I might be like kind of giving away things. But we talk about the mean, the median, and the mode. And so if you took the average, the mean, this is like the thing that you know when we talk about average, this is the thing that you know, the arithmetic average, right, is another way to talk about your mean. So the mean is like your arithmetic average. The median is if we put all their ages together and we start crossing out the last and the first one, the first and last one, until we get to a middle number, right? And so this is if you list all the numbers out and cross them. So we're not really I'm not trying to go too deep into this. But there's basically three sort of measurements that are really common that we use to talk about the middle or the average sort of person or thing that we're talking about. The mode is the one that is most used. So in this, it would be like the 65 to 70 range is the most used range, right? They didn't give us the individual ages of each person, so you can't actually figure some of those things out. They would have to give us individual ages of each person to sort of figure the average out, right? To get the exact average. So we did histograms. We did histograms with frequency. What if I did a histogram and instead of frequency, I did relative frequency? How would that change this? Would it look similar? Would it look different? Can you think about that? That's kind of a weird thing to ask, probably. Going back. That was this thing. How do we get to relative frequency? Yeah, it's going to give us
Percentage.
fractions. It's going to give us fractions, right? And so we get it. We get a percentage of this. So we're getting that percentage by dividing by a total, right? And so we're going to divide each of those frequencies by the same number. So if we go back, we look at something. Whoa, where did that go? There we go. If we divided each of these numbers by the same number, would the shape of this thing change at all, or how would it look? I guess is my question. I think
It should look kind of the same, right?
it's going to look exactly the same. Yeah, it's going to look very similar. Except now your scale is going to be different, right? Is about the only thing. We're dividing everything by the same number. So this is going to be like 19 divided by 100 and something. I don't know. So instead of this, it'd be like what, 0.19? We're dividing everything by about 100, right? You could say. And so these would be about 0.19. These would be about 0.18. And if we add all those frequencies together of everything that happened, the relative frequency always adds to what number? It's the loneliest number. Yeah, 1. Sorry.
You said it always adds to 1.
Yep, relative frequency should always add to 1. Because you're guaranteed one of those things is going to happen, right? And so we're talking about the probability of something happening. It's going to be 1. It's going to be one of those ages, right? What else?
This is your last question, right?
Yeah, this is it.
35. All right, so what I'm trying to Google search and I can't find anything, but we got a whole class of people that might come up with a good like response for me here. What I think we should do since what was that? 35 was all messed up. Is it 35? And 30 is also messed up too. I noticed that in the book. It's got that weird inequality. Let's think of a question where the answer is in a range of values, right? Numerical value for our class, and then just build a histogram on the spot for it.
What about this first one we
Nice.
did? We could do this with grades instead of doing letters.
Can we
no?
think of a funny question? Can we think of a funny question?
This guy has to know. Yeah.
Well, no, we could do it, but just think of, see, somebody here's got to have a funny question.
Abs aren't even range because you're gonna
The
have to
answer
go.
the answer has to be a number is all it is. That's all we need. All right, any volunteers? Something that would be a somewhat informative, kind of funny question that the answer would be a number. So here's oh, there's one. Jorge is right. How many times have you showered this quarantine? We need to narrow off the range a little bit. 0. Okay. What is today? Today's, let's say in the past week. So we have a well-defined day for quarantine. So really think about it. Some of you may have showered twice in a day if you worked out on that day or something. You may have skipped one, but everybody take about a minute to try and figure out in the past 7 days, how many times have you taken a shower? All right, and then I think I'll just, I'm gonna scroll through as I see everybody's names on here, and then I'll just ask you. And then I will type all of that into the chat bar for us. All right, Veronica, how many times have you showered in the last week?
Twice a day.
Huh?
Twice a day.
Twice a day? 14?
Yeah.
All right. Keeping that coronavirus away, huh? All right, Brittany, how many times have you showered in the last week?
7.
All right. Richard.
20.
God dang.
Y'all are
Yeah,
watching
some-
too much.
You have some dry skin. Ana Isa, how many times have you showered in the last week?
7 times.
7, sounds good. All right, I gotta change my page. Ian, was that a 0 you said?
Yeah, let's do 0.
Yeah, it said 0. That's great, man. Smelling funky over there. Jason. Jason, how many times have you showered in the last week?
He's thinking whether he wants to answer honestly, I think, is what it is.
Either that or he's watching Netflix right now.
Yeah. But if he does a little finger thing, it makes us think that he's thinking, you know.
Jason.
Texting.
All right, we'll come back to Jason. Tina.
5,
5 times.
7.
You said 5.
I said I said hi.
Pat, moving on. Patrick, how many times?
How many times I showered in the past week?
Yes, past 7 days.
A dozen.
All right. Some names in here. Lana, how many times have you showered in the last week?
Sorry, I was listening to a radio call.
All right.
In
Jason,
the last
how many
week, I've
times?
showered at least 14 times.
Okay. All right. Lana, how many times have you showered in the last week? Oh, she put it on there. Oh boy, 3 times? When you write it as "oh boy"
Seriously.
3 times, that sounds like you did like a armpit sniff before you told me the answer to us.
I feel like HR needs to be contacted for this.
All right, Sabrina, how many times have you showered in the last week?
Probably like 8 over like 7 days.
8? All right, Alondra.
10.
Narcy.
7.
Andrea.
9.
Romeo. Wait, what was that, Romeo?
10.
10. All right, guys. Hold on. Juan. Xavier.
10.
TJ. TJ. All right, Dina.
9.
All right, did I miss anybody?
Just me.
Who is that, Misty?
Yes.
All right, Misty, how many times have you showered in the last week?
7.
7. All right, myself, 9 probably. I work out a lot, and my wife gets mad if I don't take showers. Severs.
I got 3.
All right, so I'm going to post this up to the chat. Oh, Jorge, sorry. Jorge says 5. Did I skip anybody else? All right, if I did, I apologize, but I'm going to post the numbers right now. All right, there they are. All right, so what we want to do is create a histogram. What you're going to first do. All right, TJ is adding a 3 to the list. So everybody catch that. All right, so the first thing that you're going to want to do is look at the numbers and start to figure out what you want your bin size to be. Okay? Don't answer it out loud yet, but just think about it for a bit. Like how wide should you make a bin?
14.
All right, so considering bin sizes here, the lowest value that we got is a 0. The highest that we have is a 20. You would probably want to, oh, okay, so here's where we got to be careful though. Severs, did you talk about what's called the right-hand rule?
No, I didn't talk about that. But
Okay.
it was kind of here in the graph, but
In the
there's a
notes.
second here.
Okay.
The units that they gave were from 50 to 54, and so 55 is getting thrown in with this guy, right?
Yeah. Okay, I can't, so I've videotaped all these lessons, but I can't remember which ones were in which now. They're all starting to get jumbled up. Okay, so we have a low of a 0 all the way up to 20, but that means that you have to have one bin that's at least past 20. Okay. So ideas, the first idea I was thinking was we can either do bin sizes of like 4 or 5 because 20 is divisible by 4 or 5, but we could maybe go up one number, go up to 21, because if your bins only go up to 20, then that 120 number is going to fall over to the next side, which will look a little bit odd. I guess it's not bad though. All right, so does anybody have ideas on bin sizes? I'm thinking of making, like, I'm imagining the number 21. So what do you think maybe I'm imagining as bin sizes?
Threes.
That's what I'm thinking is 3s. Now, I don't know if that's going to turn out good. They might be like too spread out. But let's try it. Let's try it with 3s. And if it doesn't work, maybe we can redo it. It doesn't really take long to redo it.
So when you say bin size, that's your y-axis, correct?
No, your y-axis is always your frequency.
Okay.
The bottom, the x-axis is going to be your bin sizes.
Gotcha.
So our first, so all the spots you're going to mark off, like if you're looking at Sievers that he has up here, you're going to mark off the numbers 0, 3, 6, 9, 12, 15, 18, etc., right? So you're going to mark off all at 3s. If anything ends on a number that, so like there's one person that, actually there's a couple people that said 9. That means that they're going to fall to the right side of the 9. All right, so give it a shot. Bin sizes, Seaver, since you have the document camera thing, however you're doing it set up, can you at least like outline with the intervals?
Yeah, I would do like a chart is what I would do personally. So you're doing 3? And
Yeah,
so
that's
like
what I
what I was
said.
thinking is like number of bass, then you're gonna start with 0, right? 0, 1, 2.
Yeah, okay, good. All right, I'll let you take
3,
it from
4,
there.
5.
It looks good.
6, 7, 8. So if we're doing 0, 1, 2, we're gonna count out how many zeros, 1s, and 2s. I believe there's only 1 0, right? I'm reading.
Yeah, that was Ian. That was Ian.
1, 3, 4, 5. There are 1, 2, 3, 4. I believe in this range. 6, 7, 8. Here's a 7. 1, 2, 3, 4, 5, 6. I believe there's 6 in there.
Disappeared.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. There should be 21 total, right? So we always check to see if I'm missing any. 9, 10, 11 should be 1, 2, 3, 4, 5, 6, I believe. So doing a frequency table will help you quite a bit on this, I believe. 12, 13, 14. 1, 2, 3. 15, 16, 17. I don't see any in there. But 18, 19, and 20, I believe is going to give us 1. Did I do this right? Did I count them right? 6, 12, 15, 19, 20, 21. It should be 21. And we're going to say 0 in here, maybe.
Yeah, I think the graph is going to look good.
Okay. So these are the numbers we want to graph. And we're going to go up to 3. And we go 6 here. This is 9, 12, 15. This is my 0. Frequencies going from 0 to 6 is the highest number that I have. One by one here, I think we'll be okay. So between 0 and 3, I should have 1. And typically, I think most bar charts have their bars are usually filled in with some sort of color, so you can see where the bar is. You get a contrast of a positive and negative space then, I guess. Three, 4, 5. So between 3 and 6, it should be 4. Here. 6 and 9 should have 6, so it's going all the way up. Between 9 and 12, it should be another 6. Between 12 and 15, it should be 3. Between 15 and 18, there's nothing there. And then between 18 and 21, we come back with 1. We ran away. Okay. So if they're giving you like a raw list of numbers, like I personally would not deal with like that raw list of numbers. I would take that raw list of numbers and figure out what sort of like bins you want. So we're doing by 3s. So 0 to 3 is going to give me 0, 1, 2. So I'm just looking at those numbers and I'm counting how frequently they appear in the list. And so if you make a table, I think you'll save yourself a lot of headache. Who let the dogs out? Dina let the dogs out. Okay.
I did have it right.
And so if you make this frequency table, like this histogram almost makes itself here. We have frequency. I didn't label anything on this. I did a horrible, horrible job at labeling things. And so this is the number of baths over here. No, it's not. This is a frequency. This is the total number of baths. So maybe it might be worth noting. Like we said something about like histograms typically don't have spaces between the bars. So you might notice there's like a space here, but there's a space here because we had like no values in there, right? And so you might see something like that, but typically there's not like those spaces between the bars like you see in your bar graphs.
Yeah, but that spacing in the graph is important because it tells you something, right?
Yeah.
We seem to have a lot of data that's clustered together, but then there happens to be this jump and then one single value that's out there. And of course, it is the next set of notes, I think, where we talk about, I don't know if it's the next one or if it's going to be 6A, but we'll talk about what's called an outlier. And that little spacing tells us that we have what's called an outlier, and that'll be important for like how we decide to summarize our data later. I think our histogram looks good. It's almost symmetric. And, seems to fit well.
Let me go.
Here's a question to anybody. Because we had different graphs to look at, right? We looked at pie charts, we looked at line graphs, we looked at histograms, we did all that stuff. When do you choose to do a histogram? And that's open to anybody there. When do you choose to do a histogram?
Like when you're looking at a population, I guess looking at a population in one category, in a single category.
Might need a little bit more. I can see how that sounds like a good answer, but there's some more details that would need to be in there.
When you have like something that's quantitative, a quantitative situation.
Okay, that'd be the first point, is that it does need to be quantitative. You can't do a histogram without being quantitative. Okay, but then there's other things that exist. In the notes, they give you the dot plot, which is kind of like a bar graph. They give you that type of a thing. So other than just that you have quantitative, like it's all numerical data, what might that data look like? And we have some data, we did it, we just collected it. Other than it being numbers, how do those numbers look that you need the histogram for them?
They should not have less than 50.
Yeah, well, that's just, like I said, that's fundamentally wrong. You can't have like these, yeah, they need to be actual numbers. That doesn't need to be true. I think I'm having a hard time like asking the question. Nobody's.
Is it more when you're trying to find an average, I guess?
Well, we're going to be going like, eventually what we're going to be doing is taking all kinds of data, like quantitative data, and doing that and finding averages, but not just averages. We're going to look at the medians and the modes and those sort of things. So you're starting to get into the right area. Like if we look at the data, and I'm over here looking at my chat bar of the numbers, I think that would be okay to ask you what the mode was, what the most common number was, because it seemed to be like 7. Like it seemed that number centered around a spot there.
Oh, does it have to do with the distribution or like averages?
Yeah, a little bit. Again, I'm having a hard time asking the question, but I think you guys are getting right around the idea is that to choose to use a histogram, I think, number one, you want to have the quantitative data, which you said, but you're also looking at data that's well spread out. There's a variety of numbers, sort of like test scores. Like when I give you test scores, there's probably only going to be one person who gets a 94 and one person who gets a 78. Maybe 2 people will get a 73. But you end up with data that's like all over the place. So it makes more sense to put all those numbers into little bins to look
So,
at
like,
them as symbols.
looking at polling data amongst ages, right? Like that would be for a histogram.
I would need to know what the numbers are talking about, though.
But if you're talking like people amongst certain ages who voted for a certain candidate, right?
Yeah. Okay. If it's the way I'm imagining it, yes. Like you, I don't know. Just say there's a Democratic candidate. Let's go Hillary Clinton, right? Because we know she ran for president. If you went and asked a bunch of people that voted for her, we know for a fact that they all voted for Hillary, and said, "How old are you? How old are you? How old are you? How old are you?" That would be a great histogram, because you're going to have all kinds of different ages, right? You're going to have ages all the way from 18 to in the 70s, but you'd want to break them into bin sizes, into intervals, so that you can organize the data. That'd be a great example.
Are you saying people over 70 only vote Republican?
No. I'm saying people over 70 are, I don't know, man. How old do you think the oldest person is that votes?
I'd say 98.
Okay. Then 18 to 100. I really don't know. I'm sure there's some 70-year-olds that are out there voting, and they probably are Republican, yes. I don't know, man.
Just kidding.
When most of the activities for this book was written, man, there's so much that's like politics are in there. And I don't think they're pushing any agenda when they were doing it. They were just saying, this is good math to look at. Man, now that's such a sensitive topic. I try and stay away from it if I can, but it's in my mind already. We're looking at the frequency system contains multiple.
So what about credit scores?
Credit scores? Yeah. No, that'd be great. Yeah. You're asking a bunch of people. If you were really collecting data, you might be also asking a certain group of people. Like you might be asking, millennials. I don't know. Millennials, what's your credit score? That'd be great, because you have this big range of numbers that the credit scores can be in. I forget what the highest is. Is the highest 800 or is it over 800?
I think it's over 800.
860, I think.
Okay. Yeah, so you're going to have a range of values that can be all over the place, right? I mean, anywhere from let's just say 300 to 860. I don't know really what it is.
It's
but
300. It's 300 to 850.
Is it really?
Yeah.
The 300 was just a guess.
That's what it looks like.
All right. Yeah. So that would be great, because the quantitative data that you're going to get back is going to be spread out through those numbers all over the place, right? So the individual numbers are not going to be as important as the numbers that they might be, like how close other numbers are to each other. That'd be a really good one to run. That's about as great of an example as you can come up with, I think. And that you would probably do bin sizes of about 50, right?
Yeah.
In one of the next, it's either the next activity or the one after that, there's a little bit of a conversation about the bin size. And it's hard to judge. Sometimes if you make your bin size too skinny, the data gets so spread out, you don't learn anything from it. But if you make your bin sizes too large, then it might hide some of the details that are important in there. So, well, over 9,000. What are you talking about? Your credit score is not over 9,000. I can tell you that. I don't know if it goes up to 900.
It's from a meme.
I think it also depends upon what scale they're using.
That's how
800 is top.
What's the top?
I thought it was 800 was the top credit score. Like if you had
That's what I
800,
thought it was too, but then I swear I saw something that was over 800.
It
Not
said
on
like
mine, but
the FICO or whatever the heck it is, it said 300 to 850 is what it looked like.
It's 850.
okay.
so your FICO credit score is accumulation of all three credit bureaus, and that's for like buying a house or things like that.
Yeah.
I don't know. They divide it or do something. I figured you guys would probably know.
I just know how to multiply, add, and subtract. That's pretty,
And I think you are correct. It's 850 because I just looked at mine and I got an 805.
dang, look at this guy dropping numbers.
He just wanted to brag.
552.
Yeah.
Nah, is that stimulus check I just got? It boosted it up.
Yeah, 850. I just Googled it.
This is let me see.
Hey, well, if we want to brag, I got my stimulus check. That
Oh,
was great.
Credit, it is correct. Okay.
Whoop, whoop. I got paid for having kids.
Me too. How awesome was that?
I know, right?
I'm putting that back though because they're going to want that back at some point in time. Nothing is free in this world.
Well,
There it is. I'm
I
trying to
can
get.
tell you, I'm not stimulating the economy with any of that money. It's all just going to my savings. I need to stimulate my savings. All right. Well, all right, Severs, you got any other ideas?
I think we're like getting at it, but like,
A lot of this is starting to lean into our next conversation, which is
Yeah.
the
Could we
histograms.
could we do a quick example of a pie chart just because that's on our homework that's due this evening? If possible.
Yeah. Okay. Pie charts. Let's do a little bit of comparison. So histograms they've got to be numbers. Histograms have to be numbers. Pie charts can either be numbers or they can be qualitative, but most often they're like a qualitative type thing.
Percentage?
What's that?
Percents?
They do end up becoming percents, yeah. But they usually, like in the raw data, they're going to be qualitative, like it's.
Your budget?
They usually ask you a question like, what's your favorite restaurant? Or like if you had to choose between restaurants, or if you had to choose between like colors.
It just essentially another way of drawing out a bar graph.
Yeah, but what's cool about the circle graphs is that you get to see all things at one time together. Like the bar graphs, they do have that sense of proportionality. Like if you were to stack all the bars together, make one really long bar, then those individual pieces are the right percentages of the whole thing. But it's kind of hard to see it, not impossible, but it's not as easy to see it in like the comparisons of the sizes when they're in the bars, even though they're still side by side. It's just something about the pie chart I think really amplifies the comparison. I'm trying to think if I wanted us to do like some sort of a survey for like a pie chart, but those take a little while to draw.
yeah, I would say like pie charts tend to be more descriptive when you're doing like parts of a whole, like in this homework problem that you probably can't see. They're doing like percentages of like the energy out of the total, all of the energy consumed, right? Or generated, sorry.
Yeah, and you can do that problem with them if you want. I helped them with a little of the homework last time. It was,
They got 33% is what, a third?
yeah.
kind of feel like drawing pie charts by hand, to be honest, is a little bit outdated. Like you have, if you're going to do this for work or something like that, you're probably going to go put it in Excel and you're probably going to create a pie chart out of it, to be honest. Because they're going to make, it's going to be a lot prettier made in Excel than made by hand, you know, like if you're presenting it.
And as a quick comment, in my video that I do for this stuff, I drew exactly what you just drew. I do that off to the side too, and I say, this is what 25% looks like. This is what 50, this looks like what 33 is. Like, these are good baselines, at least to get a general picture going.
And so I think 2 of them are 33%. So you already have 2/3 of your thing drawn, pretty much. The other one's what, 20%, so it's a little less than a quarter. But I would say like the problem that you have in your homework probably makes a little more sense as like a pie chart than maybe doing like, you could do a pie chart with this, but it wouldn't be quite as descriptive, I don't think. I guess you could do parts of the whole class or something, but it's not quite as descriptive to me. I don't know. So I want to go. I guess you could think about it that way. So this is a quarter. Each one of these angles is going to be like a quarter of 360 a whole turn. So you can think of these as being like 90-degree angles. So that's basically kind of how they're going to do like pie charts. If you had like a what do they call it? Compass. Or I guess that'd be a protractor, wouldn't it? If you had a protractor, you could like measure the angle degree, but like I said, if you're doing things by hand, it's probably not going to be the prettiest. So they're doing a bar graph and a pie chart on that one. Are we getting into cumulative probabilities, or are we just doing like the discrete things?
Uh, Just cumulative, I guess.
Yeah, because if we look at this, like there is a sort of relation. You can kind of look at the shape of these sorts of things, right? And there's a sort of relation on like how this thing is kind of shaped. And so if you've ever heard like the phrase the bell curve or something like that, this is discrete because we're going between certain numbers. But if we flatten this thing out and look at it sort of as a cumulative sort of thing, that's where that we look for a bell shape. There's something called the bell curve. And like a good portion of statistics is just comparing different populations to like that bell curve sort of shape. There's a lot of things we know about the bell curve distribution that we can kind of use to our advantage, and we kind of use like that as our unit to do other things in statistics.
Unit, or sorry,
Yeah.
section 6A is going to introduce like that curvature shape.
Yep.
I think after that, we do talk about the standard deviation and that kind of business. So that gets closer to the cumulative.
Yeah, and so we'll start talking about the standard bell curve, basically, is what we're going to talk about. And so we'll probably introduce a lot of those sort of like topics and properties that the thing has. The what was it, 68, 95, 99? Is that what the rule's called? Something like that.
That's correct.
Do you remember the numbers? Yeah, okay.
It's definitely 68,
95.
95, and then it's like 99.7.
Yeah, and so there's a lot of sort of properties about the basic bell curve. I got room somewhere. It looks like this. It's like symmetric, and so we can use things that we know it's symmetric. It looks like that. So my X and Y axis is which is horribly drawn, but it's there. And so I don't know how much I should go into this, but there's a few things I might want to say.
I have a quick question.
Yes.
I'm looking over the homework. I'm still not entirely understanding the difference between, or I guess the uses of a histogram versus a bar graph.
They look very similar because they both have the sort of bar thing going on, right? But if we look at this one is going to be like your example of a bar graph, right? And this is going to be your example of like a histogram. Ignore that first bar that's there. But like, what is the difference? And one of the main differences is this x-axis, right? If we look at our x-axis, these are all quantitative. And so these are quantitative, and so they're going up by the same sort of number. These are going to be qualitative, right?
Okay, I get what I get that.
And so the histogram, you have something numerical on your x-axis. We can talk about averages, right? We can talk about the average age here. Here, if I try to talk about the average country, that's not going to make a whole lot of sense in regards to what's happening here, right?
Right.
Okay. And so these are quantitative. There's measurements that we can take on these. The other thing is that there's no gaps between these. These are qualitative. They're like arranged into sort of groups. And because they're arranged into sort of groups and those groups aren't like going from one to the other, like these numbers go from one to the other, there's like a bit of space in here, right? These are separate things that we're kind of talking about. Okay. And so I kind of want to make a comment like how the word I want to use is ubiquitous. Like it's used pretty much everywhere, right? And so for like manufacturing something, this could be like anything, but I'm just gonna pick something super boring. Okay. The washer that goes on this little bar I have on this chair. So if I'm like making washers or nuts, like say like that, it's going, and I want it to be like 1 inch. Well, if I'm manufacturing it, like most of the things, or almost none of them are going to come up as exactly 1 inch, right? There's going to be a sort of range, and that's sort of what this is representing. When we make things of this, most of them are going to be right at 1 inch, but like almost none of them are going to be exactly there, right? And so we have a sort of range that happens when we manufacture things. They're never exactly the number that they're supposed to be. There's always a little bit of variance in there, right? Of what the actual product is going to be from what it actually is. And so you have a population, right? You can think of those things as being a population. Each one of those numbers, each one of those little washers that you manufacture gives you a different number. And we can take that number off of each one of those little washers. And when you do that population, you're going to get shapes sort of like that with bars, right? And so what you're going to start to see with your bars is you're going to start to see that sort of like standard normal curve is going to start to come out of this, out of the pattern probably. Or it's going to look close to it. Yeah, I've probably gone a little too far ahead, a little bit. I think that's about it for this section, though. That was 35. I feel like I'm going over it now, or going beyond. If there's any questions, I'm here for questions, but I think I'm going to probably like hit stop on the recording.